I got this in today. So this is from RCbenchmark. Well, actually, a couple things I want to show you I got in today for testing. So this is a thrust test stand. So you can buy these from RCbenchmark. This one was around, I think, $700 or so, with a couple different options. So this is going to be nice for testing our drone motors, like these guys. So there's a lot of specs online about, how big, how small these are. So this one here, you can see this is, what I've got here, so this is an Emax 2205. So you have all the information that goes along with this, but we don't really know for sure, does it meet its specs? It probably does, but there's more factors that go into the efficiency, the speed, the thrust of a motor besides just these numbers right here. And so this is going to help a lot with that. So we've had a bit of a confusion. Also, that was going to work, of course, in conjunction with the propellers. So we're doing kind of a new thing coming up, me and the group around me. We want to test some of these out a little bit more thoroughly. So I just recently bought from Rotor Riot, but whatever. I think I bought about 15 different motors, individual, one at a time, and of course all the other motors that are around here. And we're going to put them up onto the thrust test stand and see how they work. And then we'll probably take something like the Dahl 5045s or 47s or some pretty common prop, and we'll put that on there and test all the motors, and we'll write down everything about them that we can find out. So I think that'll be kind of good. And of course, I will go ahead and publish results as we do this over the course of essentially forever. Then the other thing, of course, we'll be doing is picking out certain motors and then, whatever motor we go with, and then test props as well and see what we can get from that. I did also buy, so let me set this aside here. One of the options is an accelerometer, an RPM meter, so that you can obviously see how fast the propeller is going. And what else I get? A thermometer to test heat on things, so I can place it wherever I want. We were also thinking that we could use this to test batteries. So we don't have a really nice battery load tester like Bardwell does, but we could at least get some kind of value for us here as far as which one of these batteries is surviving better than the rest. And treating them, how nice is how important, because it's pretty frequent we don't really exactly treat the batteries as well as we could or should. Okay, so anyways, here is the box. So this is what you get, and these I just recently just sort of stuffed these in here. But here's the temperature probe. And again, I think this is about $30. And then here is the RPM tester. And I could have got a separate one of these, but it's nice that they have it already here. They got a bracket for it. It will go into the stand. So looking at this, it's a bit smaller than I thought it was going to be, but that's okay. That's fine. I mean, I didn't really need something huge to test this, little motor right here. And you're going to build it up like so. And so based upon the picture here, because I'm not going to put this together right now, I just wanted to show you just kind of a quick little vloggy type thing of here's some stuff that I got that's going to make life a little bit better in the future. So it here from the picture, and go ahead and check this out online. Of course, it's a better, it's an actual photograph. You're going to have a load cell right here. So you're going to have a strain gauge on this, and you're going to be able to see deflection here. Then you got a couple on the side here that you can see your torque as well. And then the RPM probe will end up somewhere bracketed onto here. And then the thermocouple, the temperature sensor, you could stick kind of wherever the hell you want. If I'm testing batteries, I could stick it over in a battery and just see how that goes. Now, the thing I'm kind of curious about is it does say that it has, it comes with some software, and I want to see how that works. How well is the graphing and the storage of all the data? How well, what does that look like? How easy is it to use? Okay, so I will open this up here. We'll see what we get. So this is kind of the main thing, I think. It should have, I believe it comes with its own ESC built in. Maybe you supply it. I was kind of hoping that you would supply it because then we could test ESCs as well, right? Okay, so here are your chips for your load cells, I guess. Okay, whatever, we're going to screw that in. USB interface over there. And really then wires and a bunch of brackets. So this is no big deal. I'll get this put together sometime. I might post this video first. I don't know, because I just kind of wanted it to be a short and sweet, hey, look what I got kind of stuff, rather than a whole big finished video of here's a thing and here's me doing something with it. This is stuffed in here in some way or another. There we go. Another one hiding down here. Boom, 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 boom. Yeah, some instructions somewhere, and we'll have this put together. Here's your load cells. So this, could we have built this? Yeah, you bet, you know. But the software and everything, it's already put together, so it's just kind of nice and easy to get. But this is your typical load cell that you'd buy, 2 kilogram, right here. You could get this from, SparkFun, Adafruit. They sell these things all over the place. If you haven't ever seen these, I actually used to build these long time ago in one of the first electronics job I had, working for a company that made giant versions of these for truck scales. So essentially you take your strain gauge, you remove material wherever you need to on said block so that it will have a flex point, a known flex point, and then when you provide or you add any kind of stress to it, that's the point, the weakest point where it's going to flex, and then you can sense that, and then you'll have to have a Wheatstone bridge over down yonder somewhere, probably in that chip that we just saw in there. And yeah, anyways, then you can turn that into that force into a reading. Oh, here we go. Yeah, so there you go, whatever. So I think this one's done. This is just a pile of brackets. I'm going to have to put this together, and then I'll show you what I got. USB cable. So I'm thinking that the software is a download online somewhere, which I would imagine. For latest version of the manual and tutorials, go online. Yeah. Okay. So there is that. So kind of put this off to the side. Lots of stuff, hopefully, to do with this in the future. So we get him over here. And then I want to show you my bigger deal. Well, I don't know if you want to say a bigger deal. It's definitely more expensive. Here you go. So this is a Siglent spectrum analyzer. This is the 3032, and I'm really happy to get this because this is the first really nice professional spectrum analyzer I have ever owned. So there's going to be a bit of a learning curve. Got to figure some stuff out here. But the idea for to have this is so now I can check. Well, I can check lots and lots of things around here, from just wanting to see, network data, the access points, that, your regular 2.4 gig there, because it will go up to, it's 9 kilohertz to 3.2 gig, up to 3.2 gigahertz. So this is a pretty good one. It's about, I think it's about $2,500, which is actually insanely cheap for a spectrum analyzer. I didn't ever think that I could own one of these at one point in time. Any rate, so yeah, I could do that kind of stuff, checking the Wi-Fi, but really what I want to do is I want to get some of the, I'll probably get some near-field probes, I'll get some, a handful of other different accessories for this, because right now I can't do jack. I have nothing for this. I've got no probes, no cables, no nothing. So then though, I can get my near-field, for example, my near-field probe, and I can grab, say, any of my quads or any electronic circuit that I'm currently working on, and we're talking about things putting off noise. You're having problems with, I remember when the 4-in-1 ESCs were first coming out, there was you know, not naming names, but there were certain brands that were causing a lot of noise that was interfering with the VTX. Now, I can't check the 5.8 gigahertz VTX, but I could surely just test for just general noise, and so that's going to be helpful there. Any of the other electronic projects that I'm working on, the CNC mills, if you see, you know, I'm still always doing those and work with those every day, even though you haven't seen a video on that in forever. I can check some of that because we've had some issues that might be due to some kind of crosstalk between, you know, the AC possibly and some of the control signals. So anyways, that's all I wanted to show you. I've got really, you know, 2 cool new, can I get these in shot? New things here that are going to make my life a lot more interesting. I'm going to have to learn a lot more stuff as well. There, let's look at this guy. He's more important. This, look at quad for scale. This is a big ass screen. It's not touch screen, but it's really nice.